morning, everyone, and welcome to this week's special NCLUG presentation for National Surveyors Week, and happy Global Surveyors Day. The path for Global Surveyors Day began back in ancient Egypt when society first used surveying techniques to divide land. Throughout the history of surveyors, we remained the pioneers of discovery in a world and in shaping our world to its current existence by exploring the unknown in Earth and in space. Fast forward to 2013, with the signing of the Budapest Declaration, creating a common worldwide celebration for those leaders, past and present. We are proud to proclaim Global Surveyors Day as a way of globally recognizing the groundbreakers, pioneers, individuals, and industry that has shaped our history and continues to be the foundation of our communities. And NCLUG is proud to offer support in this industry. Today's webinar will be on Trimble TBC training, processing survey data to bring into ORD. But first, a few housekeeping details. This webinar is a presentation, so all attendees need to mute themselves. If you have been muted yourself and you need to ask a question, you must unmute yourself individually because I do not have the ability, excuse me, to do so. At any time during the webinar, you can submit questions into the chat box. As time allows, the presenter will address as many questions as possible during the Q&A session at the end of each presentation. We will be recording this webinar and will share the link after the event. NCLUG is offering PDH credits to those who have registered on the website for this event. After the session, NCLUG will send out PDH receipts to those who have attended the live meeting. No credit will be given to those who have viewed the recorded presentation. And now, I'd like to introduce Mark White with Duncan-Parnell as our presenter today.
Hey, Tonya, thank you for that introduction. Just to let you guys know a little bit about who I am. My name is Mark White. I'm a licensed surveyor in North Carolina. Been with Duncan-Parnell for about 15 years now. I am the training and support manager. So that's my focus, is teaching people how to use Trimble software, Trimble hardware. We are the Trimble dealer for North Carolina, Virginia, South Carolina, Georgia, and Florida. So we pretty much cover the whole Southeast along the Atlantic seaboard. And I basically train people how to use the equipment and software. So Tonya had talked to me about a month ago about coming on and spending a little bit of time with you guys going through Trimble Business Center and just doing some basic processing of survey data. So in an hour, there's a lot of different things you could do there, right? In an hour, we kind of settled on doing some control work. So adjusting traverses with level data in there, alignment style. So, going from one pair to another pair, editing the data, adjusting the data, scaling it from grid to ground, bringing in level data, kind of combining different things that you might do on a project inside Trimble Business Center, getting it into a state where then we can put it into your design software. In this case, we're looking at ORD there. So I'm going to go ahead and share my screen. Let's see, I'm just going to share screen one. There we go. So hopefully you guys can see that. Let me know if you can't, but you should kind of see Trimble Business Center popped up on the screen there.
Yes, we do.
All right, good deal. Yeah, you never know, right, when you're not able to see your own screen. But what I'm going to do, like I said, is I've got a traverse, I've got a control file, and I've also got a level file that was ran through the traverse. So we're going to create a new project. We're going to bring that data in. I'll show you guys how to edit that data, get it into the shape we need it to actually do a traverse adjustment. And we're going to look at doing a conventional traverse adjustment like compass rule, and then also looking at doing least squares. So whichever way you want to go with that, show you how to do both of those in here. And taking a look at the level data and then exporting it out as a point file, so then you can go into ORD there. So the first thing I'm going to do from the main screen here in TBC is just click on New Project, and we're going to choose Survey Foot. For you guys that are TBC users, it is a true geodetic software. So if you're going to work in state plane, just make sure that you're choosing a template that's not scale only. If you're ever working in 5,000 coordinates, anything that's not a true geodetic system, that's when you want to use the scale only. But we're going to jump off with US survey foot since we're in North Carolina. Click on OK there. And all that's going to do is open up a blank project that has my unit set up. So the first thing I'm going to do is actually set up my coordinate system. Up at the top, I've got a little gear button for my project settings. And we're going to go to the coordinate system tab. You'll see by default, it's just set to default settings with WGS84 as the transformation. So just a worldwide coordinate system. But I'm going to go ahead and set this up in state planes. That's what we're usually working on, right? Especially for DOT work here in North Carolina, working on state plane. So when you open up TBC and we go to change the coordinate system, all your last used systems will show up if you've been using the software. I'll just go ahead and show you guys how to set it up if you don't have recently used in there. So first thing, we'll go to coordinate system and zone, and we'll need to select our coordinate system group. I'm going to expand this out a little bit so you can actually see. We're going to use United States State Plane 1983. Don't choose ITRF to NAT83. A lot of people see that NAT83 up there and they jump on it. That's a transformation set to go from worldwide coordinates ITRF to NAT83, and that'll shift your data about 2 meters. I've had a few people run into that issue before on jobs. So, when you're working here in the States, you're working in North Carolina, and you're working on state plane, we're just going to use United States State Plane 1983. And then for the zones, we have all the different zones around the U.S. So in this case, we'll pick North Carolina 3200, hit next. And for the geoid model, geoid 18 is the latest one. They've got all the older ones in the list. So if you happen to be working on an older project, you can choose that as well. We're going to set our geoid model quality over to survey quality. All that does is, the geoid model is a gridded file. So if it's set to unknown quality, it's just going to set the grid spacing larger. Mapping quality is going to tighten it up a little bit. Survey quality, it does not try to parse out that gridding to make it run faster, and that's what we're dealing with. And then the vertical datum, you can put something in for that if you want to, but you don't need to. It's just metadata. It's not going to affect anything. But if we're working with a geoid model and we're working with state plane 1983 coordinates, then we're going to end up with NAVD88 by default. So you could just type that in there so that anybody coming behind you knows what you use there. I'm going to leave that blank for now and just hit finish. And so now you'll see I've got my my project set up in state plane. I'm going to click OK there. And then down at the bottom of the screen here, you'll see it says US survey foot, grid coordinates, North Carolina 3200. So right now, this project is still set up in grid coordinates. And that's what the Traverse was actually run out the field with. And we'll talk a little bit more about grid and ground as we go along, because, when we're doing surveys in North Carolina for DOT, the final product is getting done on the ground, right? Some other states stay on grid the whole time, but here we do scale things to ground, so we'll kind of go through that. But I wanted to start off in grid so I could show you guys that process here in TBC. So we are in grid now, and you've got a couple of different ways you could do things. You could bring in your data. If you see over here on the right, I've got a USB stick plugged into the computer there. And on it, I've got my Trimble Access folder from the data collector. I've got a Traverse job and a Traverse JXL. I've got a control file that's a CSV file, and I got a DAT file that's level data that was run through with a Denny level run through the Traverse there. And I could bring these in any order. It really doesn't matter. For me, and maybe it's just because I'm a simple guy, I tend to like to bring in the control first. Just makes it easier for me, and then start bringing my survey data in, because the way TBC works is if I bring my control in, it works in a hierarchy. So if I tell TBC that my control points are control quality, then any raw data that's named the same thing as a control point is just going to lay right on top of it. So I didn't really have time to go through processing GPS data. So I've got a couple of sets of azimuth pairs in this control file that I'll bring in. And, I told Tonya I'd be glad to come back and do some stuff in the future. So if we ever want to look at processing GPS data, we can do that. But if I bring this file in, name it control, then bring my traverse in, and they're named the same, then the raw data is just going to lay on top of the control. Same thing with the level file, but you can bring it in any order. It really doesn't matter. So I'm just going to drag in my control first. All right, so when I bring in a CSV file or a text file like this, it just opens up with a little importer that allows me to view the data, kind of preview it, make sure it looks right, and also choose what order I want it. So right now it's in point easting northing, so I'm going to scroll down because I want to work in northeast. And you'll see I have an option for control quality or unknown quality. I'm going to bring these in as control points because, like I said, that's going to put them at the top of the hierarchy. This is my process GPS control, azimuth pair at either end. And that way, as long as my traverse file and my level file have the same names in them, that raw data is going to lay on top of this. So I'll just hit the import button now, and that's going to bring in my 4 control points. So there you'll see I've got my control at either end, a pair to tie the traverse to. And the way TBC denotes stuff on the screen, if it's got horizontal and vertical control value, you'll see a triangle with a dot. If it's horizontal only, it'll just be a triangle. And if it's vertical only, it'll just be a square. So it's a lot like what you see on the NGS website, just to make things easy. So I do have my my control in there. So now for me, the next logical step would bring in my traverse, and then I'll bring in my level data on top of that. I do have a couple of different files for my traverse. I got a .job file and a .jxl file. When you copy stuff out of Trimble Access, it'll create both of those. I like using the JXL file, but it doesn't really matter. The job file is actually the original raw data that's on your collector. The JXL file is just an XML file format of that. The advantage to using the JXL is if the guys in the field have updated their data collector and you hadn't updated your TBC, it's not going to understand how to read that job file because you have to update your drivers. But if you just pull in a JXL is version independent, so the guys can be running a newer version in the field and you've got an older version in the office and you'll still be able to talk. So that's the only real difference there. So I'll go ahead and drag and drop that JXL in. Now, if you guys are TBC users, you've probably seen this message before. It's just warning me that there's something different on the data collector file than there was in that coordinate system I set up in the office. And I always tell people, always hit the details button down here and check it out and see what the difference is. It may not be anything big. It could be that the field crew was using the wrong coordinate system, or maybe you even accidentally set up the wrong coordinate system. A lot of times, though, when I set my coordinate system up in the office, I don't assign a project height to it. I just set the office software up. On the data collector, it makes the field crews actually put a project height in. So a lot of times that's the difference. And that's what the case is here. But if I click on details, I'll see I get a side-by-side comparison. So over here, I've got the database, which is the office. And then on the right, I've got my imported file, which is what's coming from the field. And as you can see, if I look at the coordinate systems, they're both the same settings for North Carolina. But down here, I've got something that's in yellow for the project height. And again, that's just where the guys in the field are required by Access to put a project height in the data collector, and just as a jumping off point for the project. And here in the office, we're not required to do that. So it's just asking me, what do I want to do? Now, I need to let you guys know something about the way I did this project. When I ran this traverse, and I say quote unquote ran this traverse because I spent yesterday afternoon creating this traverse here in the office. A little bit easier for me by myself to create a traverse than it is, excuse me, for me to go out and run a mile long traverse. So I created this traverse yesterday, and I did it without elevations because I wanted to bring a level file in. And I know a lot of guys that'll do that in the field, that'll run a traverse. If you don't want to mess with or spend the time to do measure ups, you don't have to do the measure ups in Access, and you can just run a 2D traverse. Same with a lot of softwares. You can run a 2D traverse, then run your digital levels through and bring those in. So that's what we're looking at today. So I am going to bring in this project height because since I don't have elevations, I need a project height in the file. So I'm going to close this. I know what the difference is now. So I'm going to tell it to convert to the imported file definition. So it brings that project height in. Nothing else is going to change, right? Same coordinate system, all that good stuff. I'm just adding that 400 feet to it is really all I'm doing by changing to the project definition. And there you can see now I've got a traverse, and this is a mile long. It's running down 1010 Road out near where I live. Like I said, I keyed the information in, but it's geographically correct to follow along the road out there. So I've got that data in there now. The one thing I need to do since I brought it in from the field is I'm going to go back to my project settings and my geoid model and tell it that it is survey quality, because that coming from the data collector, since I switched it over to that, it doesn't know that that data collector is survey quality. So I'm just going to make that one change. The other thing I'm going to do is go to File and do a quick Save As. TBC does not auto save. So you just need to remember to save every now and then. I'm going to call this, call this Traverse. And it's 3:23 today. So we'll just put that on there. Save that off. So just remember, every time you do something that matters, like bring data in, that sort of thing, do an adjustment, hit the save button up here at the top. There is an auto reminder you can set in TBC to remind you to save every 15, 20 minutes, but you do have to auto save. So I've got my data in here. The first thing I noticed, there's a couple of red flags down here at the bottom. I have a flag pane down here at the bottom as well I can open up. And this just tells me that when I tied into point number 3, I was off about 1700s. And then when I did my closing angle to 4, I'm off about 1500s. So whenever I have flags, I like to look at that just to see exactly what's going on. But here I know this is at the end of a traverse. I'm going to have some error, right? So this is just my closing error showing up. For those of you that are TBC users or Trimble users, you'll know that Trimble doesn't use different point numbers. When you close in and you tie in on your traverse, it uses the same point number. So in the field, you know, I use this A3671-3 when I collected that point, and also the 4. And then when it overlays, it looks at the difference between the control quality coordinate and the field data. And that error that's showing up there at the end, that's what it's going to use to adjust the traverse out there when we run a conventional traverse adjustment. All right, so I've got my data in. I understand what my flags are. Let's look at a couple of ways you could actually edit your data. Over here on the left-hand side of the screen, I've got my Project Explorer. If you don't have that, you can go to the Home tab, and up here at the top, you'll see your Project Explorer. The Project Explorer is really handy for getting around in your data. If I expand out my points, I can see all the points that are in the file here. Anything that's flagged is going to be red. So again, I have that visual indication that there's something wrong with those points. I know what that is. It's the closing error of my traverse. But, you know, if one of these other points had a red flag on it, I'd want to look in there and see what was going on with it, right? You'll notice they all have triangles off to the side. So if I expand that out, I've got my point number, and then I've got all the data that is associated with that point. So you can see there's survey data, mean angles that are associated with all these different survey points. If I double click on one of these points, I'll get the properties box to pop up. So anything in blue can be edited. So if I had a wrong point ID, I could edit that. If I had a wrong feature code, I could edit that up here at the top. And then I'll show you where you can edit your raw data down here at the bottom under imported files. But I can look at some of this data from my mean angles. It's not going to let you edit raw data because that's field collected data. It doesn't give you the option to edit that, right? It is what it is, what we collected in the field. So that's how, if you needed to change a point number or a code or anything, you can just click on the code up here at the top, open up the properties, and change that information right there. But another really handy thing for troubleshooting your data is down here under imported files. This is where I do all my editing when I'm really troubleshooting stuff. And when I'm not doing training, I'm doing tech support. So I get all sorts of crazy files sent to me. That's why I had to create one. Most of the files people send to me are in pretty bad shape. So I didn't want to use that for my demonstration today. So down here, you'll see the different files I've brought in so far. I've got my CSV file that's just got my coordinates in it. But then here's my traverse information. So when I expand that out, you'll see there's each one of my setups. And if I expand each one of these out, you'll see there's a backsite point there. There's the keyed in coordinates that were used for that backsite. and I measured rounds on these, so I doubled angles up. There's that information. I can keep expanding that out, and here's the individual observations that were in there. So back bearing information, back sight information, front sight reversed, back sight reversed. Then my mean angles are down here at the bottom. So the nice thing about this, whether you're running a traverse or you just got some data in from the field one day, let's say they had a bad point set up. If I click on the total station icon here, the point number is in blue. So I can simply change that point number, hit F4 to recompute the project, and it's going to move all that raw data to the new point number. If you did a bad station setup and a bad backside, or maybe you flip your data around, you can change the point number here. You can come down under the observed data where you did the backside. Again, it's in blue, so I could edit that point number. So if I change the setup number, I change the backside number, all that raw data is just going to flip around to the correct point. So bad point setups can be handled there. Like I said a minute ago, I did not do measure ups on this because I was bringing in level data. But if I had a bad instrument height, I could click on my station setup again, and right here, I could change my instrument height. You can also change your measurement method. So I've had times where people have, like a Trimble robot, you can measure bottom a notch, you can measure true vertical. It's about 51/100ths difference. And I've had people accidentally enter the wrong thing in the field. So you can come in here, you can change your height, you can change your method, and then that's actually going to update all the data that was shot from that setup. So you could have 500 topo shots from there, and you change that height, it's going to change all of them automatically updated. So a lot of your raw data edits can easily be done down here. Station setups, HIs, rod readings, all that kind of stuff can be done. So if I clicked on an individual down here, you'll see here's where an individual observation, I could change the rod height. If I had ran heights out here, I could change the prism constant. I could change the custom prism type over to any of the different prism types there. So most of the errors that field crews are going to make, right here on the left-hand side under Project Explorer and Imported Files, I can go in there and I can edit that data. I can fix it. If they make a note in the project that, hey, I've got this bad rod height, I got a bad prism, I got a bad measure up, got a bad setup, we can fix all that data over here. The other nice thing for troubleshooting, if you're running a traverse, I've got my mean angles down here. I can select one of my mean angles, right click, and I can look at my mean angle residuals. So if you've turned 3 sets, I only turned 1 set here, but if you had turned 3 sets or multiple sets and you thought one of them was wrong, you can actually go in here and see which one, you might have some bad residuals on, uncheck that individual observation in there, and then it's going to recompute the project so you can kick out bad observations in there if you have multiple sets turned. Another nice thing you can do in there is right click and go to your mean angle report. And this is just going to pop up a box where it will show you, your different, when you're phase 1, phase 2, the distances, the angles that were turned, what the residuals were, all that good stuff. So you can kind of troubleshoot. If there's something outside the tolerance you have set in your settings, it's going to be red in here. So maybe somebody's using a robot and it locks on to a tail light or something like that, or speed limit sign if you're surveying down the road, or, something like that. You can catch those bad angles in there. So in this particular set, I know I've got a couple of observations that actually need to be deleted out. So I sat on number 2, backsided number 1 here, turned up to number 1, and then shot number 2. Well, I turned a bad angle when I went to number 2. So I set back up on number 1 and returned into number 2 and carried on with the traverse. So really this setup and this setup are both setups I don't need. So just as simple as going in here, selecting both of those, deleting those out, and then hitting my recompute button or hitting F4 on the computer. And now I've got that updated, got that data out of there that I don't need, and my traverse is ready to go. One other thing I forgot to say is if you're doing least squares, when I click on a setup here, you'll see I've got all my correction information, refraction, temperature, pressure, curvature. Make sure your guys are putting that information in the field. If you want to run least squares in TBC, you do need that. At a minimum, you need the curvature information, but you should have all this stuff on if you're actually running least squares. You can come in here and key it in later. A whole lot easier if the guys do it in the field, right? But that's just quick ways to kind of come in and edit your data. Once I have that all done, I've got my my traverse edited and ready. Now I can go ahead and bring in my DAT file. Oh, let me show you one more thing while I'm thinking about it. If I come up here to one of my baseline points and right click on it and choose the point derivation report, the derivation report will show you what data was used to calculate this point. So right here, I can see that the northing and easting, I don't have any elevations right now because I didn't run elevations on this, right? But the northing and easting is coming from mean angle number 8. So with the instrument sitting on BL2, backsighting BL1, the doubled angle over to BL3, that's what is being used to create this right now. So we'll kind of take a look as we bring in other data and we adjust it. How does it affect our point derivations? That's why I wanted to point that out there to you. So next thing, I got my traverse in, I've edited it, I got all my data where I want it. Next thing I'm going to do is bring in my level file. So this is a level run with a Denny level run all the way through the project from the point number 1 all the way over to point number 4. So I'll bring this information, just drag and drop it in. When it comes in, it is going to open up the level editor for TBC. You can see, again, just like the raw data coming from the instrument, anything we actually shot in the field is grayed out. We can't change that. That's actual raw data. We can change the point numbers. We can change whether something's a benchmark or it's a computed point, but those are really the only things we can change in here. Now, right now it's set to use raw elevation, so that's what we're seeing down here. I am going to adjust this run here in just a minute, so it'll automatically change over to adjusted at that point. Again, like I said earlier, one thing you'll see, these are in blue, so these point numbers can be edited. I do want this to be a benchmark, the first one, and then if I scroll down, I want the last point to be a benchmark as well. And that's how the level run was entered in, but if you needed to, you could set those as benchmarks. So you can do the drop down there and you can set it to benchmark. You can tell it's control quality and you can key an elevation in. So if you need to change that, it's in blue, you can edit that. But I do need these point numbers to be the same as they are here in my file. So I can real quick do some editing here. I can put a dash mark in because if they're the same, if they're labeled the same, then it's the raw data is going to overlay. So I need to put little dash marks in here. That'll just take a second. You could bring this information in and do it inside TBC, but it's just as quick to do it here in the editor. And then it's going to understand that these elevations need to fall right on those control points. And now those points that are horizontal only in the job will have good elevations on them. So it's just a quick way, whoops, that should be BL8. To bring your level data in. We're going to adjust it next, so it's going to fall right on there. And then this is A3671-3, so it'll match up there. And A3671-4. All right. Now, I don't want to compute an elevation for this one, A3671-3, because that is one of my control points, already has a good elevation. It's not going to compute 4 because it's a benchmark. And let me scroll back up to the top. I will uncheck number 2. I don't want it to create an elevation on number 2 either. And it's not going to create one for number 1 because, again, it's a benchmark. A couple of other things down here at the bottom, creation options. I can allow network adjustments, which is going to create delta elevations for this, or I can say prevent further adjustment and create control coordinates. I'm going to adjust this level run and let my Denny level run be my control because I ran it from one benchmark through the job to another benchmark. Up here at the top, you'll see it closed really well, less than a couple of thousandths. And if you've ever ran digital levels, if you got a good digital level, you're going to get really good closures on it if your elevations are good at either end. So, I got a good closure here. I'm just going to go ahead and create control quality coordinates and let these be my elevations. I'll adjust the horizontal data. I'll do a traverse adjustment. I'll also show you how to do a least squares adjustment, but I'm going to keep this level run as my control coordinate. So I'll set that down here. The other thing is I'm going to tell it to ignore the descriptions, and that way it's not going to try to, any descriptions that are in here, it's not going to try to tag them onto what's already in my traverse file. So once I get this set the way I want it, get all my names updated, tell it which ones I want to create and not create, I will choose to adjust this run. And you could have multiple runs in here too. So like if you had your L line, you had all your Y lines too, you could adjust each run one at a time. You could adjust this run first. And then if you had a Y line coming off one of your baseline points, you could hold that baseline as the benchmark and run it out after you've adjusted this one too. So that's another nice thing you can do in here. I'll click OK. And now you'll see I've got all these adjusted elevations. I've got all my corrections in there. So when I click OK, it's going to take these, since they're named the same, and it's going to drop these good control quality elevations on top of my traverse. So I'll just click OK there. It's telling me, hey, these already exist. Do you want to merge them together? So I'm going to check the box at the top and tell it to merge all of them, because again, that's why I wanted to name them the same. I want it to lay those on top of there. So now I'll import those in, and you'll see a quick change the way things look on the screen. Again, I've got horizontal and vertical control quality on these points on the end. I got a triangle with a dot, but now you'll see all these baseline points have a square on them, which is a benchmark on the NGS website. So basically all these have control quality elevations now. And if I look at one of these points, I'll pull up BL3 again, right click on it, go to my derivation report. You'll see the horizontal is coming from the traverse. The elevation and the ellipsoid height are coming from that DAT file, which is coming from my level data. So derivation reports are nice if you ever have a question about where your data is coming from, because when you start mixing GPS, total station, and level data together in the same project, it's good to understand which one is controlling your coordinates. And then later on, when we actually run an adjustment, we'll see that the adjusted coordinates are now controlling our coordinates. But right now, total station is doing horizontal. The elevations are all coming from our level file. All right, so I've got that in there. I've edited my traverse data. I've edited my my level data. Now, before we actually do any adjustment, we need to scale this job up to ground if you want to work on ground. You don't want to scale it after you do the adjustment. TBC is going to get mad at you because, you know, when we scale things, the way TBC works, we hold one point fixed and all the distances are going to get scaled out from there. So our coordinates are going to change. Well, the software doesn't want to change adjusted coordinates. So it's going to tell you it's going to rip the adjustment out. You're going to have to readjust. So it's a good idea to go ahead and get everything moved to ground before you do any adjustment there. So to get this to ground, I'm going to go to the survey tab. I've got my local site settings up here. Click on it. And I need to select which point that I want to scale from. So, you know, if it's a large project, a lot of times people like to scale from the beginning. A lot of times people want to scale from one of the beginning control points, so I could do one or two. This is only about a little over a mile long here, so I'm not going to get much warping, you know, by holding one at the end. So I'm going to go ahead and control and pick point number 2, because that's the point I first have my instrument on. Again, though, you're just picking what point you want to keep grid and ground equal at there. So I'll select that point. That's going to grab the northing and easting. You'll notice it did not pick the elevation, it just highlighted it. The reason it does that, it makes you go back and select the elevation separate, because if you were working up in the mountains or something like that, and you had a large elevation change in your project, this elevation here is what's going to be used for the elevation factor that is part of your combined factor that gets inverse to create your ground coordinates. So you want to make sure you have a good representation of the elevation of your project. So if you had a large elevation change, maybe you want to pick a point in the middle, or you want to key something in there. Not a whole lot of elevation change, maybe about 30 or 40 feet on this project. So I'll go ahead and use the elevation to the same point. Select on that there. But again, that's why it makes you do it separate, okay, so that you get a good representation there. So I will check the box for use ground coordinates. At this point, I could key in a scale factor if I had one I wanted to key in, or I can tell the software to go ahead and compute it. You'll see when I click on that, the scale factor is 3 zeros and an 11 coming up next. So about 11 hundredths per 1,000 feet. If I kept this on grid and this is a 5,500 foot traverse, then I'd have about 5,500 hundredths worth of error in there if I didn't, account for the difference between grid and ground there. So we're going ahead and scaling it up to ground now. When I click on OK, this point number 2 is going to be held grid and ground equal. Everything else is going to get scaled out from there. So I'll click OK. And now you see down at the bottom, US survey foot. I am now using ground coordinates, still North Carolina 3,200. All right. So we brought in our control. We brought in our traverse, edited it. We brought in our level data, got the point names so they'd match up, adjusted that level run, dropped it on top of our traverse data, and then we scaled it all up to ground. So at this point, our vertical data is adjusted. We've got it on ground coordinates. Now we just need to adjust our traverse data to get our final control package done. Couple of different ways you can do that here in TBC. The first way I'll take a look at is just doing a regular old compass adjustment. So also under the survey tab, I have the option to adjust a traverse. Click on it. Now TBC does require you to name your traverses. The reason is because once I adjust this main traverse, if I had Y lines going off, or I had a couple of little traverses maybe where I looped around to locate some properties or something like that, I can run sub traverses. I could add that job data in here, hold this baseline fixed, and if I traversed off some of these points, I could create sub traverses under it. So you can have multiple different traverses in a job. I'm going to call this BL for baseline, hit the create button, take a sip of my tea. And then the way the software works, it's going to look over here. If I look at the imported file on the left in my Project Explorer, you'll see I've got all my different setups and they're in chronological order, right? So the software is going to look at that and it's going to say, hey, the first time you set the gun up was on this point right here, A3671-2, which lines up over here. A lot of times I like to check that because I deleted out those first couple of setups, right? Because I knew they were bad, or maybe your guy put a note in the book that they were bad. But we don't always get that information in the office, right? Sometimes we'll get data and we're like, why are there all these setups over here? Which one is the right one for the traverse? Well, if I look at this, I can see that here was my point that the gun sat up. I backsighted number 1. I turned rounds, and my rounds went to BL1. So I can look at this raw data and I can see, yeah, that is my first setup point. And then if I go to the next one and expand it out, it was on BL1, backsighting number 2, and turning rounds to BL2. So I'm like, okay, this makes sense. I can see how it's working, right? So over here, that's what the software is doing. It's reading that raw data, putting it in chronological order. So I can just hit the plus button to add that one as my first setup. Again, the software sees that BL1 was coming up next. But, let me do this. I'll drop back just a second. I'll trash can these real quick. You could choose one of these other stations to run your traverse from. So if you wanted to start in the middle for some reason and go, you could do that. But you can always select which one. Obviously, we want to start at the beginning and go. I'll hit the plus key. Again, it's just reading the data. If you wanted to make a change, you could. I'll hit the plus key again. About the third time you hit the plus key, it realizes, okay, I see the direction he's going in, and I'm just going to select it all. So you could hit the trash cans to remove different setups if you needed to. If there was ever a time where maybe a field crew busted a setup the first time, you sent them back out, they returned the angle and brought it back in, then you could use the drop-down arrow to choose which setup on that point you wanted to use, the first one or the second one. So that's why you have the little drop-down arrows there. But here I know my first setup up at the top was 3671-2, and then if I scroll down to the bottom, my last setup was on 3671-3. Under the station orientation, my back sight was number 1. That's correct. My foresight was number 4. So all of that looks good. You do have different options though. So, if you had done something different or the field crew had done something different in the software region incorrectly, if you had multiple observations, then you could choose the correct ones there. But once I get all that information in there, I just need to choose how to set up my adjustment settings. I could do proportional to distance or equal proportions. I like to adjust my angles proportional to distance, but you have the option either way there. For the vertical, again, proportional to distance or equal, or in this case, none, because we ran digital levels through it. Don't need to adjust the vertical here. I'm going to hold my digital level information. So I'm going to adjust the angles and the distances, but I'm not going to adjust the vertical. And then I can choose either to do a compass or a transit. We'll do a compass right now. Manually or automatically. As a surveyor, I'm never going to do anything automatically, but that's in there. They put that in there for the machine control guys or people like that. So if a coordinate got updated, one of these control values got updated, it would automatically rerun the traverse for them. As a surveyor, I always want to be the guy making that decision whether to rerun the traverse or not. So I always leave that on manual. So once we've got all our information in there the way we need it, we can go to preview results up here at the top, and we can make sure that our traverse closes okay. Again, this is all the information we saw on the page before. Down here, I can see my before adjustment, my angular misclosure, my northing misclosure, easting misclosure. So it was a 5,580 foot long traverse, and it closed at basically 1 in 32,000, right? So not the greatest traverse in the world, not the worst traverse in the world, especially for a linear traverse tied between pairs. Then I can see after adjustment, once I apply the adjustment, what's it going to do? My angular misclosure goes to 0, obviously, and it actually makes it a little bit better. I'm going up to 1 in 41,000 right there. All right. So if I'm happy with that, I can go ahead and hit the apply button and close that out. I can wanted to show you guys this because you probably would want to print out a report with all your traverse information. So there is a report that it'll generate by clicking on the report button up at the top there. Maybe. Computer's running a little slow. There we go. So that's all our information showing up there with all our adjustment information and a nice little picture of the traverse at the end. So then you could save this off, save it as a PDF Word file, and just save it off to put into your survey file there and have your traverse adjustment information there. Now, when I close this, you'll see now my points, instead of being green, all my adjusted points have purple lines running in between them. That's just so I have a visual indication that I do have a traverse adjusted or a traverse adjustment there in the job. So I can quickly, when I open the project up, I can see that it's adjusted. You'll see that the lines between the control are still green. They weren't adjusted. That control was held fixed. They weren't adjusted. So it's just the stuff that got adjusted that's actually purple in there. I do have a flag on it. By default, TBC sets its tolerances to 1 in 50,000. So that could be changed just by going up here to my settings, my computations, and traverse. And I could change, by default, it's 25,000 for vertical and 50 for horizontal. And I'm at 41 right now. So I could change that if I wanted to, if I didn't want to see the flag. I am going to hit the save button real quick. Or I tell you what, I'm going to undo it and then save it, so then we can do a least squares adjustment. But anyway, that's got our traverse adjustment in there. Now, if I go and I look at BL3, I told you we'd look at the derivation reports to kind of see how those coordinates are getting calced up. Now my derivation report, my horizontal coordinate for BL3, 4, 5, 6, 7, 8, 9, they're all coming from traverse adjusted. The coordinate for the elevation and the ellipsoid height is still coming from that level file because I locked it in as control. So now I have a traverse adjusted northing and easting, and I've got my digital level data for my vertical. So I'm going to hit the undo button real quick. One of my favorite buttons when I'm working with data. I'm going to undo that traverse adjustment because it's not really going to do us any good to run a least squares adjustment on already adjusted data, right? So Undo that. Now I'm going to hit the Save tab just so if my computer blinks, I don't lose anything. And I'll also close this device connection just to give us a little more room. So traverse adjustment, done. What if we want to do least squares? So up at the top under the Survey tab, we have an option for Adjust Network. I can click on that, and you'll see anything that's labeled a control point can be held as a constraint. So the pair at either end is control, so you'll see those at the top here. And then all those baseline points, you see they can only be checked for vertical for the elevation because they are control points as well. So that's why you're seeing all of those in the list here. In a lot of cases, you might only have your 2 points at the beginning and the end, but because I brought in digital level data and made control out of those elevations, they're showing up in the list as well. If you don't have any points showing up that you can hold fixed, it's because you haven't assigned control values to any of your coordinates. So in that case, if you needed to, you could double click on a point here in the list, go up to the Add Coordinate button, and tell it that it's control quality for whatever you want to hold as control, hit OK, and that's going to add control quality to that coordinate. And I'm just going to cancel because I've already got control on that point. Then those points are going to show up in your list, okay? So you have to have points that are denoted as control quality in order to hold anything fixed in a least squares adjustment. So the first thing we need to do when we get into least squares is we need to get our settings right. Then we need to do a minimally constrained adjustment. Once we have a minimally constrained adjustment and a good weighting strategy in place, we can go ahead and do a fully constrained adjustment. So the first thing we're going to do is set our settings up. And what we're really going to do is set our weighting strategies up. And when we're doing that, what we're doing is telling the software how good our equipment is so that it can, assign error values to the different equipment that we use. So under default standard errors, if I'm using a total station, excuse me, I always set that to project settings. And then under the total stations tab, you want to set your default standard errors up to what your instrument specs are. So you can look at the data sheet for your gun. Like if this was a half-second S9, I wouldn't want to leave this on 1 second. I'd want to come over here and I'd want to set this at half-second. So I had my really good Traverse gun out there, not running my 10-second. So I got my half-second instrument, and then also that S9 is rated for 0.003 of a foot or 1 millimeter in the distance. So I can set this up to 3,000. So whatever your instrument says it's spec to, that's what you want to put in here. You don't want to be running a 5-second gun and have it set to 1 second. Conversely, you don't want to be running a half-second gun and have it set to 5 seconds, right? You want the software to understand what equipment was being used. And then on your centering errors, this is really going to depend on how good you keep your equipment up, right? If I take my equipment in and have it calibrated on a pretty regular basis, and I've got field crews that can actually set the instruments up and do it properly, then I'm not going to have very much centering error in here. Trimble recommends starting off with 0.002 to 0.003, which is right about a millimeter. Now, if I know that I've got a gun that the tri-brac hadn't been adjusted in 3 or 4 years, maybe I bump that up to a couple of millimeters, like 0.007. If I'm backsighting a tripod with a tri-brac on it, again, I'm going to start, and I know it's adjusted, I'm going to start off in that 2 to 0.003 range. If I'm if I'm backsighting a pole, and it's got a 40-minute vial on it, I might set that to 100th even, right? If the tip's rounded off, maybe even a little bit more. The key thing is you want to put in realistic numbers for your weighting values. You don't want to put in something that's going to give you too much wiggle room. You don't want to put in something that's not going to give you enough wiggle room. We're setting our weighting for least squares to look at this information and go, okay, here's how much error I should expect when I do the adjustment. So I don't have height errors in here. But again, if you're measuring with a tape and you're not using the bottom notch on a robot, so you're having to wrap the tape around, maybe you bump it up to 0.007. If you're doing bottom of notch, keep it in that 2 to 0.003 range. Target, same way, depending on how I'm measuring it up, I might give a little more, a little bit less, but just, do some testing. Don't just guess at this, but put real information in here. I'm not going to do anything with my leveling data, but if you were adjusting that, you could change your settings here as well. I do want to go under my network adjustment, and under general, I want to set it. If I was going to do a vertical adjustment, I'd leave this at yes. I'm going to set this to no. And then you get the choice whether or not you want to use individual observations or mean angle results. So if I use mean angle, it's just going to use the mean angle. If I want to use each individual observation, I can set it to individual observations. There's pluses or minuses to both of them. I don't have time to go too in depth with that this morning, but I'm going to use individual observations for this. Many different ways to skin that cat, and we could get into a long discussion on it, but I'm going to go with individual right now. Other options, if you had property corners in here, you're running an alto or something, you could set it to include the side shots so that you get air ellipses on your side shots as well. If I've got topo data in here, I can ignore the side shots, because when the control points get adjusted, the raw data that's tied to them, those side shots are going to move with it. So generally speaking, unless I'm trying to do an alto report, I'm going to leave that on ignore. So for this example, I'm not doing vertical because I got level data, and I'm using individual observations there. Got my default standard error set up properly. I'll click OK. Now I'm ready to do a minimally constrained adjustment. For a minimally constrained adjustment, you are going to constrain the minimum information that you need to do an adjustment. Generally speaking, for a traverse, for a conventional survey, that would be 1 point and an azimuth. All right, if I'm doing GPS, it's just 1 point. If I'm doing total station, it's 1 point and an azimuth. That constrains me into the coordinate system. So I'm locking my data to 1 point, a northing and easting, and I'm locking it into 1 azimuth for a direction. So in this case, since the gun started off at point number 2 and my first backsite was number 1, I'm going to choose to constrain number 2 in 2D, and I'm going to come down here where it says add an azimuth constraint, and I'm just going to select point number 2 for my first point and point number 1 for my second point there. And that's going to automatically calculate that azimuth between the two. So I'm locking down number 2 horizontally, and I'm locking down the azimuth between 2 and 1. And this is going to do a minimally constrained adjustment. What that minimally constrained adjustment is going to do is it's going to adjust the data just holding that minimum information. So it's not going to warp my measurements to the other control points down here at the end. It's going to adjust this freely. And what we're looking for is we're looking for outliers, which are any observations that don't fit statistically with the other ones. And we're looking to make sure that that weighting strategy that we just keyed in is a good weighting strategy for our data. All right, so once I get that in there, I'm going to click adjust. It's going to pop up and tell me that I still have these 2 red flags down here at the bottom. Are you sure you want to keep going? Yeah, I know what those red flags are, so I'm going to hit yes. And it's going to process the data there. You see some air ellipses show up on the screen. You can see that since I held a point down here fixed, the error grows the farther away I get from it, right? And that makes sense because that's the direction our traverse went. We know we started off with 0 error here because that's the beginning of our traverse. And we know we got like 1700s worth of error when we get down here because that's how we close. That's what the flag popped up and said. So that makes sense that our error ellipses are getting worse as we go down the job there. But what we're looking at is the reference factor and the chi-square test and the degrees of freedom. Those are the things that you want to look at for this minimally constrained adjustment. Our reference factor, if the weighting we did is a good weighting estimate, we're telling the software expect this much error going into it. When it adjusts it, if it finds the exact same amount of error that we told it to look for, that reference factor is going to equal 1. We had this much pre-adjustment error in there. It adjusted it. It found this much post-adjustment error. If they're equal, it's going to equal 1. If there's a little bit less error, it's going to be below 1, which is what we have here. If there's more error in the data than we estimated, then it's going to be above 1. But anything between like 0.9 and 1.1 is usually going to pass the chi-square test, which the chi-square test is just looking at your degrees of freedom, which down here is the number of redundant observations we have. It's going to look at that. It's going to look at, the quality of the data. Do you have any outliers? What are your mean angle residuals? What are your distance residuals? All that good stuff. And if everything looks good and it all fits together statistically, and the error estimates were correct, you're going to pass the test and your reference factor is going to be close to 1. If you fail the test, it's not uncommon to fail the test the first time. You've got a couple of options. Look for, you don't really want your reference factor above 2. It gets above 3, you've definitely got an error in the job, and it's probably going to be an outlier, and I'll show you where to look for that in just a second. But, you want it, if it does fail and you're pretty close to 1, let's say it's 1.5, Trimble has a tab in here. You can go to weighting and you can click on this star and click on this star, and that will set a new weighting strategy based on the amount of error that was found in there. And then you can adjust it again with that updated weighting. You could also go back to your project settings and you could tweak that weighting that you manually put in there. Again, you want to make it realistic. You don't want to just enter some numbers in there so that it passes, just like you don't want to use this automatic feature in here if your reference factor is over 2 or 3. That's when you got to start looking for bad data. But right now, everything looks good here. So I'm going to click on my adjustment report real quick. And I got 4 minutes left, so I got to bring it home fast. But here in the report, I can scroll down. I'll see, here's my control coordinates. So there's a little bit of distance error between 1 and 2, about 100th or so in the easting. I've got that 1400th, 10th in the other coordinates. We knew that was coming up. That's our closing error down there. What I'm really looking for is how much error do I have in here? Are my coordinates being adjusted a lot? What are my point error ellipses coming out to be? Again, the farther away I get down to the other end, the worse my error ellipses are, right? Because they're starting off as 0 and then it's growing as I go down. This is what I'm really looking for, is any outliers. Any outliers that I have are going to be on this list, the reduced observations up at the top, and they're going to be in red. So if my reference factor was high and I failed the chi-square test, I'd look here. Chances are I'm going to have 1 or 2 outliers, maybe 3 or 4 outliers. Those are just measures or measurements that statistically don't fit with the other data. And that's one of the beautiful things about least squares is you can do a traverse adjustment with a compass rule, but if it busts, it doesn't really point you to which observations are bad. A least squares adjustment will adjust your data, but the thing I really like about it is it's going to show me where my outliers are. It's going to point me 9 times out of 10 to the observation itself that's bad. I can disable that. I can return it in the field, and now I've got a good traverse. So that's one of the beautiful things about that. Here we don't have any outliers. So at this point, I've got a couple of choices on how I can fully constrain this. I've got a good minimally constrained adjustment now. If I wanted to hold this other point number 3 in the azimuth down here, let's say you had a little bridge project you were working on and you set your control with VRS, shot it multiple times and averaged it. Your data is not super tight if it came from the VRS. So you might only want to hold a control point at this end, control point at this end, and hold the azimuth either way to adjust to, so you're not introducing any of that distance error between the points. I could lock down number 3, and then I could add another azimuth constraint and just tell it that here I want to go from point number 3, click on it there, and then I want to go to point number 4, and it's going to count that up. Now I've got the 2 control points here and here held fixed, and the azimuths going out to the pairs. And now I could adjust this, and this will do a fully constrained adjustment, but it's just constraining 2 points and 2 azimuths, right? Again, my reference factor is fairly low. I passed the test, but you can see there's a more even distribution now, right? Because it's going from 0 to 0 here, coordinate value, holding the azimuths on either end, and it's adjusting that out. So if I look at this report real quick, you'll see the change in the error and how it's distributed. Scroll down real quick. You can see now my control fits pretty good on either end, but you'll see these errors are a whole lot smaller now, right? Because it's being evenly distributed out through there. And my air ellipses are a whole lot smaller now too. And they're bigger in the middle instead of being at both ends, right? Because they're going to zero out at the ends and they're going to be a little bit larger in the middle there. And now also, if I go to a BL point over here, this BL3, right click on it, look at my derivation report. You'll see now that my horizontal is coming from the adjusted coordinates, the northing and easting is coming from the adjustment, and the vertical's still coming from that level file there, right? So just keeping up with how our coordinates are coming. Now, real quick, and this will be the last thing before we export the data out, I'll hit cancel here. And if I wanted to, actually, I'll go back to the constraints and I'll take these out. And if I wanted to lock down the coordinates at either end, if I felt like I had good control, maybe this was static, these were static points at either end instead of VRS points on a regular job, big job, I could hold the points fixed and adjust it. And you'll see now it went up just a little bit because now I'm adding in that error between the distance error between the 2 points, not just holding an azimuth. So it failed at this point, but it's still not very high. It still looks good. So I wouldn't go back in and rescale it. The only time we set that scaler in there is in our minimally constrained adjustment. Here, I just know that, excuse me, my reference factor is a little bit higher because now I'm taking my measurements and I'm warping them to my control. All right. Again, I could look at the adjustment report, make sure I don't have any outliers in here. Statistically, everything's locked down. My air ellipses are about the same, a little bit more now, where they were right around 100th. Now they're about 100th and a half. And my total station observations are reduced. There's no outliers in there, so everything looks good. All right, so now we've gone through a couple of different iterations. We brought our data in. We've edited it as needed. We've scaled it to ground. We've done a regular traverse adjustment. We've done a least squares traverse adjustment on it, right? So now if I wanted to get my adjusted control out, I can just come over to the side here. I can select those points there, and under the Home tab, I've got a few different exports I can do. Generally speaking, if we've done all our data reduction here in TBC, all we really need to do is export out a point file to go into ORD, or really any CAD software, right? Because then we've got our points that are going in there. If we had topo data in there, the codes are going to be on there, so we can auto process our line work in ORD if we needed to. But under the custom tab, I have an option for point northeast elevation and code. This is going to spit out a CSV file, so if you need it in ASCII, you can edit that. All I have to do is say, where do I want it to go to? I'll spit it out on the desktop, save that, export it out, and now I've got my point file out there on the desktop. I will show you a few other exports you can get out of here. Under the CAD tab, you could take your data out as a DWG, DXF, SketchUp, GIS. You can send it out as most of your Esri file geodatabases. KML, KMZ, if you want to share this with a customer, with a client, so they can look at it in Google Earth and see what you did. And then survey, if you needed to send it back to your guys in the field, you could send it out as an Access job or a Survey Pro job. So, point files, CAD files, or survey files, or even GIS files to get it out to people, depending on what the stakeholders on the other end need. All right. Well, I ran over just a little bit. It's 12:03, but that's really all I had to show you guys. So if anybody has any questions or anything, I'll be glad to stick around for a little bit and answer any questions you guys have.
Thanks, Mark. That was awesome. I'm sorry, I'm echoing in my ear, so I apologize for that. We did have one person who had raised their hand, Tom Porter, who had raised his hand to ask a question. So Tom, if you wanted to ask your question. Maybe Tom? I believe he has taken his hand down, so perhaps that was a mistake. And then
maybe,
there was a
maybe
question.
I got lucky and answered his question by mistake.
Maybe you did. Maybe you got to it and he didn't have a chance. I do have a question that says, why would I go through all this in TBC and export to ORD? Well, I mean, that's a legitimate question, but there's a lot of surveyors, I'm only speaking from my own experience, who are more familiar with the TBC software and find it more comforting to actually do the adjustments and everything in a software they're familiar with, and then still be able to bring it into ORD so that they can make that, make that choice and then bring it in for to be able to submit in a DOT format or another client who needs their stuff in ORD.
Yeah, I mean, really, it's about what you're comfortable with, right? We're going to have to reduce our data somehow, some way. Some people might want to reduce it in their CAD software. Some people are going to want to reduce it in a package like TBC. But that was the whole point of the exercise, is just getting your data reduced so that way when you do draw it up in ORD, you've got it reduced in the easiest way possible.
So, and then another question was, what are other formats that this will work with? Is Trimble the only one?
Oh, as far as like bringing data in?
I mean, there's so many different survey packages that you can bring data into, but we just went in through Trimble. I mean, is that how you would answer that? I don't mean to answer your questions.
Oh, no, that's fine. So there are, like, unfortunately, you guys are, I'm sure, aware that a lot of stuff is proprietary, right? You can bring in, I know that with level data, TBC will import TopCon level. Sorry, I think I accidentally muted myself. I was going to say, unfortunately, a lot of stuff is proprietary, and, manufacturers don't always share their information back and forth. But I know you can bring in level data from Leica and TopCon. Trimble has written importers for that. As far as job files, I'm not really, I know I've brought in some Carlson stuff before, but like stuff from Magnet or stuff from Leica software, I'm not really, I don't believe that it will come into TBC properly. So this would be more geared towards your Trimble users or your Survey Pro users. But yes, you could use RW5, RAW, TDS, that kind of thing. Exactly. I just saw somebody pop that in there. An RW5 file will come in, TDS will come in fine. Trimble owns TDS, but and I have done some work with some Carlson data before.
Okay. That looks to be the end of all the questions. And Mark, I wanted to thank you for spending your time with us today. I got some useful information. I hope others did too. As a reminder, PDH credits will be PDH credit receipts will be sent out to the attendees soon. And stay tuned to tomorrow's NCLUG presentation, which will be Bentley Open Roads Designer and ORD survey update. If anybody has any suggestions for future NCLUG topics, please send those emails to events@nclug.com if you want to request Mark to come back and continue on with his training. I thought it was an awesome thing. We can come up with some more ideas on that. Be sure to tell others about becoming an NCLUG member. It's free, so they can get invitations to upcoming events. And that's all we have today. Thank you for joining us, and we look forward to seeing you guys tomorrow. Thanks, Mark. I do appreciate your time.
Thank you. Take care, guys.
Thanks.